Yeah, so we'll begin the session for today. Good morning, everyone. Today we will be discussing one of the feature of while designing the operating system. Okay, so what actually we are going to discuss in today's session is all about the uh, structures of the operating system. Structure in the sense that what are the various different kind of methodology that we can adopt while designing the operating system. So those things we will be discussing in today's session. So there are four different kind of OS structure that we'll be discussing: simple structure, layered approach, microkernel, and the modules. Okay, so first of all, simple. Okay, before we go about anything, any of these types of OS structure, we should always, okay, being operating system designer, we should always think, we should always give a concern about how well we can engineer the design, we can engineer the operating system. Okay, so we need to basically understand that how well we can design, how well we can engineer the operating system so that it functions properly and gives the user all necessary facility and features that user wants. Okay, so to engineer properly, one of the simplest approach that everybody is aware and is very common, that is top down approach. In case of top down approach, what you can do is that you can divide the entire task in small functions or the modules, okay, and then implement that at the lower level. Okay, that is the one of the very basic way of designing or adopting the methodology for designing the operating system. So, so somehow the or the other, we need to always think that how well we can engineer uh, the operating system so that we can design the operating system in such a way that it functions properly. So now we will look into the simple approach. Now in simple approach, the idea was about, like, it has not, the designer of the simple approach structure have not thought that the such kind of operating system designed with the help of the structure will grow in size. So a simple structure can be adopted in a situation where it can be implemented for a very small dedicated systems. Okay, so simple structures can be thought of that way. However, okay, one of the example of the simple structure was MS-DOS. Okay, so MS-DOS stands for Microsoft, okay, Disk Operating System. The designer of this operating system has initially started the design of the operating system, thinking that okay, I am going to work with the limited features and the facility that I'm going to use it. Okay, so thinking that they have adopted it, this feature, they have adopted this methodology. So the thing out there is that we want the efficient operating system, but as and when demand is increasing, this simple structure was not doing well. Okay, so that's why MS-DOS is eliminating. There are so many other things that is not there. So the designer of the operating system, that is this kind of operating system, MS-DOS, they didn't thought that they will grow in popularity at that level. Okay, so they have thought only that okay, I will make a very simple operating system that will work with the very limited kind of features and facility. So initially, whoever is a designer of the simple structure will always think that okay, it has to work in a small scale, it should be simple and with limited functionality. So, and the main idea about adopting this simple structure is to is to put the features, okay, it to put the maximum functionality in the list space. So you can consider to be as a proverb or most functionality in list space. So that is the kind of proverb that such designer were adopting it. Okay, and such kind of methodology adopted for the designing the operating system is known as a simple structure. So one of the example of the simple structure was the is the MS-DOS. Okay. So now, what are the various different problems that you will find in this kind of structure? So until unless you don't know about the type of problem, you will not know about the drawback of it. Okay. So so here the problem was like the any application program where, as you can see in the diagram, the any application program is able to access the device driver. See, any system program or the application program are able to access the device driver, and it is not good for the operating system because device drivers are something very restricted and very close to operating system, not the application program. So application program should be running at the user level, not at the system level. Now if the application program is trying to access and manipulate the device driver, then it is working at the system level and it is not wanted feature. Okay, and this is not what we want. Another example of the system, another example of the simple structure is uh, traditional or the original Unix system. But before that, I would like to point out very important thing in the simple structure is that the designer of simple structure have failed to adopt the modular concept. They failed to adopt the modular concept. So that's why you can see that any program is accessing any kind of feature. So they fail to do that. Okay. So to avoid to overcome such kind of demerits, the designer of the Unix operating system had tried to incorporate modular feature in the original Unix system by dividing the features of the operating system at a different level. Okay, so the original Unix system designer have separated different feature, and one of the module is the kernel module or the kernel layer. So in the kernel layer, there are so many different kind of uh, um, system programs and the programs that is necessary for their operating system to execute and to run. Okay, so the designer have kept all necessary information related to operating system functioning in the kernel. Okay, but as and when the time was progressing, the size of the kernel was increasing. Okay, the size of the kernel was increasing, so the drawback of that, when the size of the kernel is increasing and when the size of the entire operating system is also increasing, one of the difficult problem that the user will find, that the designer will find, is the problem of debugging and the maintenance. So in entire simple structure, whether it is a MS-DOS or whether it is a Unix operating system or the original Unix system, then in both example, the main problem faced by the designer of the operating system was maintenance was becoming difficult, debugging was becoming difficult. Okay, in case of MS-DOS structure, the entire entire operating system was looking like a monolithic system, one single system as a whole. You can see, have a look over here in the diagram. The entire system is looking like a very monolithic system. So we don't want that. Okay, because in such kind of system, maintenance will become difficult, and if there is any error in somewhere in the, maybe in a device or a resident system program, then at that point of time debugging will become also easier. Now if anything is wrong over here, okay, it is very crucial to identify the error. Okay, that's why debugging becomes difficult. Next we will see why now original Unix system was becoming difficult, because as you can see over here that there are so many programs in the kernel. Okay, see, as and when time was progressing, this size, here I have placed only limited number of features that was placed in the kernel level initially. Later on it was added. Okay, there were some more features that were added at the kernel level. So thereby it increases the size of the kernel, which we don't want. Okay, because debugging and maintenance become easier. So this design of the design of the operating system using the simple structure follows basically a monolithic structure. Okay, which lead to uh, problems of uh, debugging facility and problems of maintenance. Okay, so debugging facility will become difficult and maintenance become difficult. So these are the problem of the simple structure, and the example of the operating system which follows such kind of simple structure is MS-DOS and original Unix system. Okay, so now okay, now thinking from the point of view to make the operating system easy for maintenance and easy for debugging. Okay, uh, people were following layered approach. Okay, people were following layered approach. Now, what is a layered approach? Okay, so it is layered approach is also one of the methodology adopted by the operating system designer to design the operating system. In layered approach, okay, the entire monolithic system is divided into small modules called the layers. Okay, so each layer is also known as a level. Okay, so that's why the name is given as a layered approach. So in layered approach, entire monolithic system is divided into different layers or levels and were implemented at that level only. So the in every layer, so every layer has a name. Okay, starting from layer number 0, the innermost layer number 0, and the subsequent layer number 1, and grow in outward direction, and the outermost layer is known as a layer n. I repeat, the innermost layer is known as a layer 0 and the outermost layer is known as a layer n. The innermost layer is known as a hardware level layer. Okay, hardware is actually physical hardware, and the outermost layer n is known as a user interface. So if anything is to be done, okay, we need to identify which layer it belongs and then implement it. Okay, one of the feature of the layered approach is that, okay, the outer layer can access the feature and facility of inner layer. For example, the layer 1 can access the features and facilities of layer 0, and similarly the layer 2 can access the facility and features of layer 1 and layer 0, and similarly user interface or layer n can access all the facility and features of layer n-1, n-2, layer 0. So this is the normal basic methodology adopted by the layered approach. Okay, now what is the advantage of layered approach? In case of layered approach, the in case of a layered approach, the debugging facility become easier, and design of the operating system will also become easier. So that's why simplicity in construction and easier debugging are the two main advantages of layered approach. So they adopt this layered approach based on the top-down approach. So example, okay, sorry, problem. Okay, there are problems with the layered approach also. Okay, there are problems with the layered approach also. But before I talk about the problems, I would like to give you the example of layered approach. So the layered approach, there are different versions of the Unix operating system that uses the concept of layered approach. That I repeat, there are different versions of the Unix operating system that uses the concept of layered approach. And some of the another common example that you might be aware of it is the Windows NT. Okay, Windows NT stands for new technology. I don't know whether you have used or not. And in our time, we used to have, I have used the Windows NT operating system. Okay, it had follows the layered approach. Okay, in addition to the other approach also, so which I would not like to name it out at this point of time. So one of the example is that there are examples of the layered approach are different versions, hybrid versions of Unix operating system, and the Windows NT. The Windows NT had failed due to some reason, which I am going to discuss in the problems or the drawback of the layered approach. So, what are the problems that layered approach may encounter? Okay, so there are one of the biggest problem that is faced by the designer of the layer approach is that how do I define the layer? Okay, how do I define the layer? Okay, for example, I should know. Okay, you can see over here in this example. In this example, you can see over here that the file system is one layer, communication is one layer, IO device is another layer, virtual memory is another layer, process and hardware. Okay, these are the layers. Now, how do I know that where should I keep file system? Should I keep the file system very close to user, or should I keep the IO device very close to user? I do not know. Okay, so that is the problem faced by the layered approach, because so for example, let us take one example. Suppose there is a virtual memory. Again, the main concept of the virtual memory is to perform the memory management. So keeping I think you have heard about the backing store. So where we keep our data, backup data in a virtual memory. Okay, so that is that portion backing store is a part of the memory management technique. So now we should always keep in our mind that the memory management has to be in always above layer or outer layer than the backing store problem. Okay, so the subroutines defined for memory management has to be in the outer layer than the virtual memory management technique, which has to be in the lower layer. So but unfortunately, if we keep in any direction, any order, so we may face problem. So we don't want that. So that is the problem. So the problem is defining a layer in which features or which routines has to be implemented, and organization of the layer is very crucial, because we want the features of the lower level to be accessed by the outer layer. So that is the one problem. And another problem is like um, uh, efficient uses. Okay, efficient uses of various devices. So those things you can go through on the book also. So one problem I've discussed, which is very common. I hope I had made it clear. Next is the microkernel approach. Okay, now there was a problem with the layered approach. Okay, because in case of layered approach, okay, organization of the layer was difficult. Okay, now coming to the point, microkernel approach. Now, in case of microkernel approach, the people were trying to adopt a different kind of um, methodology for designing the operating system. So there was a researcher, okay, there was a researcher who had introduced the concept of microkernel approach and have given the name of the operating system as MAC, MHCH. MHCH is the MAC operating system, okay, very commonly used, okay, and very efficient one in comparison to previous versions, that is layered and the layered approach and the simple approach. So name of the operating system was Mac, and the very commonly used example that has adopted the microkernel approach is the Mac OS X kernel. Okay, that this is an example of OS that was traditionally used by the Apple company. Okay, so which is considered to be an efficient one. So now, what is the objective of the microkernel approach? Okay, because in case of layer approach, the size of the kernel was large. Okay, so in any previous versions of this previous version of the methodology adopted by the different designer, the problem was the size of the kernel. Okay, as and when time was progressing, the size of the kernel was increasing, like as it was increasing in the Unix operating system in different version. Okay, so the size of the kernel was increasing, thereby it becomes difficult for maintenance and difficult for debugging. Okay, so to avoid that problem, microkernel was introduced, and the name of the OS given by the designer was the Mac. And one of the example of microkernel approach is Mac OS X kernel. Okay, here I've written its structure, it's a general structure, but the example is Mac OS X kernel. Okay, so the idea of microkernel approach was to remove the non-essential features and facility from the kernel level to a user level or the system level, because in a kernel we cannot put each and everything. There may be there may be so many information at the kernel level, it is implemented at the kernel level. So those features and facility which are not important at kernel level were identified and were implemented at the system level or at the user level. Okay, so thereby making the size of the kernel in small size, and the advantage of that will be very easy. That is, debugging becomes easier, maintenance becomes easier, and your system will become fast. Okay, because there is nothing to hang, because kernel is running always all the time. It is maintaining your computer system. So all the non-essential services and applications that were built on the kernel level were transferred into a user level at the system level. Okay. Another main important aspect of the kernel microkernel approach was to provide a communication facility. Okay, so how you provide the yes,
Then Unix system.
yes. Hmm. Yeah. Who's the girls here from this section?
Yes, sir.
Yeah, tell me, Kritika.
So we were taught about the simple architecture starting from there.
Mm.
Then the Unix, the basics of that, and then about DOS.
Then after that, hmm, upload.
Some micro
Um,
some
yeah,
microkernel.
yes. Ayushi, na? Okay, microkernel. So
Yes,
I'll
sir.
just give you a brief about it. Okay. All of you, please. Coming online means I want to interact with you sometimes. So I want you guys to be online and be with me. Okay. So that is my objective. Okay? Because otherwise I'll record and then give you. So what I was talking about, I had talked about the simple structure, which is basically a monolithic approach, monolithic structure, which is very in which there is a problem of debugging problem and the maintenance problem was there. Example of simple structure was MS-DOS, okay, and another example was original Unix operating system. Okay, so there are so many problems that I have talked about it. Next, in order to um, overcome the problem of simple structure, layer approach was introduced that uses the top-down approach for dividing the entire operating system into a small layer. Okay, and outer layer can access the features and facility of inner layer. And the problem of layered approach was how to define the different layer, which facility should be inserted or implemented in which layer, and how to organize this layer. That is one of the problem. And again, there is something called microkernel approach that I was talking about. In case of microkernel approach, uh, the main idea was about the ease of extending the OS. Okay, and another advantage of using microkernel approach was to like maintenance of the kernel should become easier, and debugging also should become easier. How they have adopted it? They have removed on non-essential features and facility from the micro level and implemented them at the system level and at the user level. So that was the main thing about the microkernel approach. Okay, another main aspect of the microkernel approach adopt the communication facility between client and various client program client means user program and various services that it is requiring. Say for example, it may require printer, it may require memory, it may require to create a process, etc. Okay, so for those kind of thing, all message passing facilities should be provided by the optic system. So another advantage is of extending OS, because since whatever you want to implement is, suppose you want to install something, okay, some feature, okay, so you will be basically installing the feature at somewhere outer the area apart from the kernel. Okay, so if you want to add some feature, you need not recompile the entire OS. So that is the advantage of the microkernel. I repeat, if you want to add some feature, okay, into the operating system, then generally in case of monolithic, you have to recompile the entire operating system again to use that feature. However, in case of microkernel approach, if you want to add some feature, okay, that feature can be added at user level or at the system level, not at the kernel level. So the advantage of doing so is that you need not recompile the entire OS, because you might not know that what is the amount of time required to recompile the OS. Okay, so for the simple Unix operating system, in order to recompile the operating system, it takes 2 to 3 hours. Okay, so that is also in case of very efficient system. So you need to add the recompile if you want to add features. Okay, that is some of the features of the microkernel approach. These are the features. Okay, you can have a look in your free time. Now coming to the point, problem. Okay, so the problem of microkernel approach is that as and when the system function increases, the performance was reducing. Okay, the performance of reducing, you can see this feature. Okay, you can see this degradation in the performance in the Windows NT. Okay, at that and the time, there was a time when Windows NT stands for new technology. At the time, there was a time when this operating system was released by the Microsoft, but due to its too much facility and features implemented at the system level, the performance of the computer system was reducing. Okay, the performance of the operating system was reducing. So that's why the Windows NT did not played for a quite long amount of time. Okay, so immediately after Windows NT, Windows XP was released in the market. So this is all about the history of the microkernel. Now next is the Solaris. Okay, sorry, modules. Okay, one of the example of OS of um, that one of the example of operating system that has adopted this modules architecture or the methodology is Solaris. Solaris is one of the example of operating system. Okay, now in this way of uh, implementing or designing the operating system, okay, there they have implemented different modules. So you can see all these are different kernels. Okay, and there is some core kernel over here. And it provides a communication. This kernel provides a communication facility between these modules. So these all the modules that are organized in this way around the kernel is known as a modules. Okay, so the modules architecture is implemented based on the concept of object oriented programming paradigm. So based on the object oriented programming paradigm, this operating system was designed, or you can adopt this modules architecture using the OOP concept. Okay, and There is nothing much to say about the modules part. It's very, very simple. I just give you a revision on it. So there is in modules methodology, okay, in modules methodology or method, the designer of the operating system have implemented different features in different using different modules. Okay, so device driver is one module, scheduling is another module, file system is another module, like that way. And then and then and there is something called core kernel, which provides the communication facility between modules and will interact with each other. Okay, so that is the main task of the modules. Nowadays, okay, just to give you a brief about the of OS structure in nowadays operating system, there are different architecture that has been adopted by different designer of the OS. Most of them now uses a hybrid system. Okay, hybrid system means in addition to, for example, I think it's better to understand from this. Microkernel approach is hybrided with layered approach. So this is a one example of hybrid system. Okay, hybrid system or hybrid architecture for designing the operating system. Okay, so okay, that's all for today. That's all for today. If you have any questions, please ask. Hello.
Sir,
Yeah.
will modules be an optimal approach or architecture?
Uh, if you see the various standard architecture or various standard methodology, the most optimized one is the modules. Okay. As I've already told you that the theory from theoretical point of view, I'm saying it's a module, but from practical point of view, most of them uses the hybrid approach. Okay, the latest operating system, most of them uses the hybrid approach. Okay, and I cannot tell what kind of hybrid approach they have adopted it, but example I can say that the hybridization example means layered approach can be hybrided with the microkernel approach.
Okay, sir.
Hello, sir.
Yeah, please raise your hand and then okay, because I need to know who is asking the question. Yeah, Simon, tell me
Yeah,
please.
sir. What kind of approach does Windows 10 use?
I don't know. Please explore on your own. Okay. Uh, most see as of now, already told you that they uses the concept of hybridization. Most of the because I am teaching only from the bookish knowledge point of view. Okay, so the latest one currently in the market, I repeat, currently in the market, most of the operating system uses the hybridization concept. Okay, but from as per the syllabus, I'm only giving you the basic thing on the background knowledge, so that if you try to explore what is the OS architecture followed by the Windows, okay, you can explore on it. You'll understand what kind of architecture when they say modular or when they say microkernel. Okay. But olden days, I can say, in olden days, like for example, when Apple had first used OS, it was the Mac OS, Mac MACH, no? Microkernel approach. They have adopted Mac. Okay.
Okay, sir.
Simon, you can explore and you can please give me back. Okay, what Windows 10 have approach, but most of them uses modular name. I not module with other hybrid technique. The book also says that. Okay, modules, some one of the base methodologies out of this four. In addition to this, or in addition to one of this, okay, some additional thing has been adopted by them and is considered to be a hybrid method. Okay, so that's it.
Okay, sir. I'll search it.
Yeah. Any questions? Yeah. Yeah, please, Sayantan.
Yeah, sir. Sir, is the approach for GNU same as that of Unix, or is it different?
Sorry.
Sir, the approach for
Unix.
GNU, sir, is it same as that of Unix system?
GNU means that GNU of Unix.
Yeah, sir, the Linux systems, वगैरह.
Are you trying to
Sir,
compare like
is it,
Windows and MS-DOS and GNU and Linux?
yes, sir. Sir means, sir, is the approach similar? Sir, Linux systems and Unix, are they similar or they are different?
They are same, na? They are same. Unix is a separate operating system, and because if you see your comparison is quite conflicting over here, because in Windows is something and DOS is something. Okay, although nowadays in your system, in your computer in which Windows is installed, the another OS MS DOS is also installed. Understood. There are two OS. One is DOS and another one is Windows in your normal system. Whereas in case of Unix, it's a one system. Understood.
Yes, sir.
Your comparison is conflicting. Okay, you cannot compare Windows OS in which DOS is installed with the Unix in which GNU is already there. Okay, so I can
Okay,
say
sir.
that as of now, I can say that Unix is one operating system, MS-DOS is another operating system, and Windows is another operating system. Okay.
Okay, sir.
Any questions, please?